How did you come across MaxIQ Space?
So we were first introduced to MaxIQ via the ThinSat program offered by Virginia Space a few years ago. And that was a program for which we were all partnered to work with the X-Chip kits. And the kits were the introductory level payload offered to schools for integration into tiny slice of bread sized spacecraft that were furnished by the program. And so it was a very easy way for first-time schools in space to click together a usable, interesting scientific payload for a real spacecraft without getting too bogged down in a lot of circuit board design or getting derailed by a little bit of a learning curve involved in soldering. We could have schools that wanted to get into space for the first time just click together a payload and start getting science data on the ground, and then eventually science data from orbit. And that's how we first used the X chips. We proceeded through the 1 year ThinSat program, and we started playing with the X chip sensors, and then we moved on from there to some more custom or customizable options that MaxIQ offers, and then even our history as we've moved on even further and done even more custom designs for our small sat nanosatellite CubeSat program. And so the X chips were really sort of like a first step up into the nanosatellite world to start designing payload and subsystems.
So you've been using the technology since 2017, I believe,
Yep.
and how are you utilizing it? I mean, you're a university, and we kind of like did this thing here for high schools. So what makes it special for Princeton University?
There's two things that are a good fit for Princeton's program. The one is our nanosatellite program is currently primarily mechanical engineers. It's offered out of our mechanical and aerospace engineering department, and we primarily enroll mechanical engineers. And our mechanical engineers want to work on mechanics. They want to work on the spacecraft vehicle, they want to work on the bus, they want to work on the structure, they want to work on deployments, but nanosatellites are inescapably electromechanical projects. And so the X chips, because we can rapid prototype circuit boards and electronics and sensors and microcontrollers, we can just click them together. We can do pretty robust electromechanical projects just by clicking together the X chips, but still save time in the school year to prioritize all the other aspects of small satellite design. So we don't have to spend all of our time doing circuit board design and soldering. We can diversify into the full multidisciplinary field of nanosatellite design because the X chips let us rapid prototype the electronics of the project so quickly and easily. The other piece of it that I think is magical about the X chip ecosystem and the MaxIQ ecosystem is there's a lot of electronics and STEM CubeSat kits around. There are almost a dime a dozen, but MaxIQ is the only provider that I know who really prioritizes the big goal of trying to get their kits on big launches. So MaxIQ offers just the standard small scale high altitude balloon launches that everybody's doing as a nice, interesting launch proxy for schools that want to do some kind of launch in their curriculum, but they try to go bigger. So they offer the small high altitude balloon launches, but they also offer they also offer large NASA scale balloon launches integrated and offered within their curriculum packages. And then they go even bigger. They offer true orbital operation of the kits via the ThinSat program. And now we're offering a ride of the kits to the ISS with a real SpaceX launch to a real orbital mission on the ISS. They offer integration into their kits and curriculum of suborbital rocket launches. So they're just going bigger with bigger launch ambitions than any other STEM nanosatellite kit that I'm aware of. And that's really gravy for us because the students really get motivated to be on a real rocket launch or a real giant NASA balloon launch, rather than a small scale balloon launch conducted in the football field, out back of the school. So it's really motivational to the students and towards their learning experience to know that there is a big deal launch at the end of the school year.
So where do you hope this ISA program goes?
So our new ISS program that Princeton is enrolled in MaxIQ's new ISS program. We're customers of the program and we bought a few launch slots on the first launch. It is, to my knowledge, the cheapest, easiest, most accessible ticket to a real SpaceX launch into real orbit. And so I see it, I hope it expands. I hope we do follow-on cycles. I hope we expand enrollment. And because every school in the world that I know of that does any kind of STEM wants to launch something into space for the first time. And I think, I mean, we're at a unique point in history where that's actually doable by almost any school. But I think that the MaxIQ ISS program is the cheapest, easiest first time ticket to space for schools. So I hope schools that are looking to get into space for the first time look at it as a really accessible way to do so. And then it's a nice stepping stone to move on to other CubeSat or nanosatellite ambitions for any school that wants to get into CubeSats. There's a very steep learning curve, and it's pretty hard to go from 0 to 100 in the CubeSat discipline. But getting your first experience in space and getting your first student handiwork into space via MaxIQ's ISS program is a really easy, really affordable, accessible first-time stepping stone into space. So I just hope it expands, and I hope it helps. I hope it helps a lot of schools get into space for the first time.
Great. Thanks, Mike. I think that's it.